Hello folks, coming up next we have Shani Peled. Shani is a senior cloud security researcher at SentinelOne who started her journey in cybersecurity serving in Israeli intelligence as the only female hacker on her team. That's an impressive credential, Shani. After defending critical infrastructure, she transitioned to offensive security, red teaming with some of the biggest Fortune 500 companies. She brings the sharp offensive mindset to uncovering the vulnerabilities in cloud and AI infrastructure. Today, Shani is going to share her work on exploiting AWS SageMaker with us. So with that, let's give in to her. Please welcome.
Hi everyone. My name is Shani Peled. Thank you all for coming today. Today we're going to discuss SageMaker AI notebooks abuse. We will see some cool attack scenarios and POCs. So I came all the way from Israel to present you this one. So let's start. Yeah, long flight. 15 hours flight. Yeah. 15 hours to LA and then from LA to San Francisco. Yeah. So before we dive in, I will introduce myself. My name is Shani Peled. I'm a senior cloud security researcher at SentinelOne. I started my career at the age of 18. I served in the Israel Intelligence Corps as a cyber defender. I served there for 2 years.
Is it the units 9068 something?
Sorry, I couldn't.
The unit something for the...
Yeah, A200, yeah, that's correct. Right after my release, I joined an Israeli cyber company where I worked as a red teamer for 4 years. I attacked dozens of Fortune 500 companies and I've seen a lot of real cloud infrastructures. And then a few months ago, I joined SentinelOne. Probably most of you are familiar with SentinelOne. In Sentinel, I'm part of the cloud security research team. I mainly focus on offensive cloud and AI research. And basically, my goal is to break real-world infrastructure. And that's it. All right, now that you know who I am, I think we can jump into what we're going to cover today. So, first we will do a quick one-on-one, just to make sure that we're all aligned on SageMaker, Jupyter Notebooks, Jupyter Cells. Then we will discuss the quick setup mode of SageMaker. It's made to be fast and easy, just one click and it creates everything for you, a notebook, a network, and most importantly, a default IAM role. We will talk about it very soon. Then comes the spicy part of the talk. It will be literally from cell to shell. We will see how an attacker can start from a single Jupyter cell and then eventually take over the cloud environment. We will see real POCs. And then we will wrap it up with some takeaways, what defenders should look for. And basically, the goal of this talk is to make sure that your AI workflows will not be your weakest link in your cloud environment. So, for those of you who are not familiar with SageMaker, SageMaker is a cloud service that makes it easy to build, train, and deploy machine learning models. You can think of it like a managed lab in the cloud where you can do experiments with AI without worrying about setting up servers or software. Basically, AWS creates the infrastructure behind the scenes for you. Jupyter Notebook is an interactive environment where you can write and run code. You can see the results immediately and you can document your work. Everything is in one place. It's very popular, specifically in data science and machine learning. And then comes the Jupyter Cell. It's inside the Jupyter Notebook. In the Jupyter Cell, you can write and run pieces of code. And before we start, I just want to remind you, probably you are familiar with it, the shared responsibility model. So basically, AWS are responsible for the security of the cloud. It means that AWS are responsible for the physical infrastructure, the servers that will be up 24/7. They're responsible also for their services, if it's EC2, S3, Glue, etc. They're responsible for them to work properly and for them to not be vulnerable. but there comes our responsibility as the customers, our responsibility for the security in the cloud. It means that we're responsible to protect our data, to manage our identities, applications, network configurations, operating systems, etc. So in this talk, we're going to talk about defaults in AWS, but it's our responsibility to be aware of that and to protect ourselves. So when I started my research, the first thing that I needed to do is to create the SageMaker domain, basically the SageMaker environment. I noticed that there are two options. The first one is the quick setup. It's very fast, one click. Everything is created for you automatically. The second option is the manual setup, where you have to create your own VPC, IAM roles, and many more configurations manually. So now, being honest, like most of the people, I chose the quick setup option. Come on, if AWS is offering a big shiny button setup for me, who is going to say no for that? But as you will see soon, the easy button also hides some interesting security risks behind the scenes. So that's how the SageMaker Studio looks like after I set it up. It's very user-friendly, the GUI is very nice. I totally understand why data scientists love it so much and use it. It's very easy to go. And then I actually wanted to understand what is going on behind the scene when I created the SageMaker domain. And two things that popped up to my eyes were, the first one was the default execution role. As you can see here, a default IAM role was created when I created the SageMaker domain. It's called Amazon SageMaker execution role, and then you have the timestamp. This is the template. And the second thing is the network mode, which you can see it's public internet access. So with these two, I started. I wanted to see what is going on there. And as you can see here, I entered my notebook. For the beginning, I wanted to understand what my context is. I typed this very common command, and I understood that the notebook is attached to this default role. So that was my starting position. In addition, I saw that I have a default internet connectivity, as I said before, and like a good red teamer, I immediately established a reverse shell. You can see here the command that I typed in the notebook, and here you can see this is a screenshot from my C2 server in the internet. I did it without any restrictions. As you know, like most of the organizations do not monitor Jupyter notebooks and commands that are executed on Jupyter notebooks. So you can stay under the radar there. And then I was able to extract the credentials, and then I had two options now. I wanted to start to do some things, so I could either use the credentials in my workstation or from my server, or to perform everything from the Jupyter cell. So I chose the second option just to remain under the radar and do it less suspicious. So I just want to keep in mind that the whole attack scenarios were executed from the Jupyter notebook, from the Jupyter cell. So at this point, I realized something important. The default SageMaker executor role contains a lot of very permissive permissions. We will see it soon. But I didn't want to treat it like a checklist of risky permissions. Instead, I asked myself, what real attacker would do with these? And so rather than just listing these permissions, I started to build real attack scenarios to understand how attacker could actually abuse these. And that's what we're going to see now. So now here comes the spicy part of the talk. We will see the first attack scenario. It's called glue data poisoning using S3 permissions. So a quick brief on AWS Glue. Basically, AWS Glue is a cloud service that helps you to move, clean, and organize data, especially if it's stored in different places. For example, if you have raw data in multiple S3 buckets, you can use S3 to automatically read the files, structure it, clean it, and then you can ask the data. You can query it like it's a database. So I try to understand, here's my notebook with my role, I try to understand what glue permissions are attached to it, and surprisingly, I saw so many glue permissions that are attached to this role. And in addition, I saw the default S3 permissions are attached to this role. So you can see that I had the ability to get object, put object, delete object, and list buckets on every S3 bucket in the AWS account. It was not restricted to specific S3 buckets of SageMaker, it was to the whole account. So the combination of both made me think that I can do something here. So for these attack scenarios, I use the glue permissions and S3 permissions. So I started to do an S3 enumeration. Everything is from the notebook, and as you can see here, I had the permissions to actually list all of the S3 buckets as expected. Then I started to download the sensitive files. You can see that I even was able to download Terraform files, which is very, very sensitive. Then I started to enumerate the glue databases and tables in order to understand what data does the SageMaker is using. Here you can see that I'm actually able to get the tables data, the tables metadata in order to understand the structure of the data. So here I chose to focus on real-time predictions just for the POC. And with the S3 permissions, I downloaded the whole data and deleted everything. Yeah, that was very nice. And then within my workstation, I created fake real-time predictions because I had the ability. I knew what is the structure of the data because of the glue. And then I just uploaded it from my Jupyter notebook because I have the permissions to upload data to every S3 bucket within the account. So let's sum it up. The starting position is my notebook. As we said, I have the data exfiltration channel for the whole time because of the default internet connectivity. Then I was able to list, read, and write buckets. I was able to create, update, and delete glue. And then together, this gave me the opportunity to extract, alter, and change sensitive data. And by doing so, I was actually able to poison the data that SageMaker is using. It can mislead the models, etc. Now comes my favorite attack scenario. It is called abusing Cognito IDP for privilege escalation. So for those of you who are not familiar with Cognito IDP, Cognito IDP is a cloud service that manages user accounts, logins, and authentications for your app separately from AWS IAM. These are like application users. For example, if someone is signing in to your app with the application user, you can just give him temporary access to S3 buckets, for example. You can grant roles, AWS roles, to application users, combine them together, and then give them temporary permissions to the account without creating an actual IAM user. So I discovered that my notebook is attached with multiple Cognito IDP permissions, very, very privileged ones. I was surprised. As you can see here, I have a lot of, like, I can create admin users, I can add users to group, I can list everything. So that was great for me. And for the attack scenario, I used these permissions, admin create user and admin end user to group. As you can see here, I started to enumerate the IDP user pools, and the interesting group that you see here is the ID admins, which is also attached to Cognito IT admin role, which is an IAM role within the AWS environment. And I just created a nice and short Python script to create the user and to add it to the group. And as you can see here, the user was automatically created and added. And then I just authenticated with this user and got a JWT token and decoded this one. And as you can see here, this is the decoded JWT token. You can see here that I have the evil user, and then here you can see that I actually got the IAM role of Cognito ID admin role, which is attached with permissive privileges within the account. And by doing so, I was able to escalate in the environment. I just want to add that not all organizations are using Cognito IDP, but if they are using, you need to keep in mind that this relation is not straightforward. So from SageMaker, you can actually escalate using Cognito IDP. So to sum it up, the notebook is attached to some Cognito user pool permissions. It helped me to take over strong users and group, and by doing so I could take over web services and also the attached IAM roles. And this was a very nice one. I was very happy to manage to do this one. And now comes the last attack scenario for today, persistent control via ECR and SageMaker. So ECR, probably most of you are familiar with it. It's a cloud service that stores container images. You can push your images there to your repositories, and then services like ECS and EKS can pull and run them. So surprisingly, my notebook was attached to multiple ECR permissions. And then an interesting thing came to my mind. I discovered that the toxic combination of ECR and SageMaker permissions can give me some cool thing. As you can see here, I had permissions to create ECR repositories and to put images. I was able to put images, the permissions to put images are only to repositories with the name SageMaker, but I could create as any repository that I wanted. So basically what I did was to create a repository, which is called SageMaker blah blah blah, and then to push my malicious image there. And the combination with the SageMaker permissions of create model and create endpoint, it made me very happy, because I will just let you know what it is. The SageMaker model is basically a packaged version of machine learning model that's ready to be used. It includes the model artifacts and the infrastructure of how to run it. And the SageMaker endpoint is basically a live service, kind of EC2, that will execute the SageMaker model. So I decided for the POC to create a backdoor image. So you see, as you can see here, it's a very, very simple one. This is the reverse shell.py that I used for the image. And here I pushed it to my repository. You can see the SageMaker repository. And within the Jupyter Notebook, I just created a model that will use my new image and created an endpoint. You can see that I chose even the instance type, and it is running. And I just got the reverse shell from the SageMaker endpoint. Yeah, it was very nice, thank you. So basically, it's not on the notebook, it's on another instance. So it gave me two things. The first one is absolutely a backdoor, and the second one is like a lateral movement to another place. So it's great. So here's the brief on this third attack scenario. I started from the Jupyter Notebook. I had list, read, and write permissions to ECR, and I was able to create the SageMaker endpoint that will execute my backdoor. And of course, I have the exfiltration channel. So here I created like a table, so you can take some pictures of these if you want to check it in your environment. I summarized it with the required IAM permissions and the attack scenarios related to these. Let me know that you're okay, great. The lessons learned from today's talk. So first, I would recommend you all to follow the principle of least privileges, to never assume that AWS default roles are safe enough because they're often too broad or powerful. You need to give specific permissions as much as you can. Sometimes it's hard, but it's very, very important. The second thing that I would suggest is to detect and fix default misconfigurations and to remember that sometimes easy default setups introduce major risks. The third thing is to continuously monitor real-time activities, and this one is very, very important because you cannot just set up a notebook and endpoints and forget about them. It's very important to keep in your mind that they are alive and exposed components, so you need to treat them this way. And the fourth thing is to isolate AI from critical infrastructures. Notebooks and endpoints, they often look innocent, but as you can see here, they are not. So I would recommend to separate as much as you can your AI environment and your lab environments for sure from your production infrastructure and sensitive data systems. Thank you so much for being here today. First, you're all invited to connect me via LinkedIn, and second, here's the link to my full research, and there you can find some more attack scenarios. I presented it here only 3, but there are 5 or 6, and every POC is there as well, and that's it. Thank you so much.